Guys, welcome to today's maths lesson. Today, Tuesday, 9th of February, we're starting our new bit of work on perimeter. We're going to be measuring and calculating the perimeter of rectangular shapes in centimeters and meters. Now, you might not know what perimeter means. If you might already know it. If you don't know, that's fine. Don't worry, because we're going to look at it today. But we're going to be doing it for rectangular shapes. So for our recap, we need to know what a rectangular shape is. So I want you to have a think about what are the features of a rectangle. What do you know about rectangles? And then really quickly, can you add the following lengths? 6 add 6 and 4 add 4. Now, you probably don't need to do this on paper. You could probably do it in your heads. But pause here, have a go, have a think. Maybe have a chat with someone at home, and then we'll come back and we'll talk about it together. Okay, so what are the features of a rectangle? So we know that a rectangle's got 4 sides, and all of the sides aren't the same size. We've got 2 sides. I'm going to draw lines on them so that you can see. So the one with 2 lines, let's make it red so it stands out a bit bigger. This side with the 2 red lines and this side with the 2 red lines, they are the same size, the same length, and they go in the same direction. Now, what it means when these lines go in the same direction, it means that they are parallel. And those parallel sides could go on forever and ever and ever, and they would never meet. Okay, they'd always be side by side. And then, so we've got those pair of parallel sides, and then we've got another pair of parallel sides here. So we've got 4 sides, 2 sets of sides, both the same length, like both in each set at the same length, they're parallel. We've got 4 corners, and all of the corners are of an equal angle, and that angle is 90 degrees. It's a right angle. Lots and lots and lots and lots of different features of rectangles. Where have we seen rectangles in real life? Let's have a quick think. So most of you are probably looking at a rectangle now, you know. You're either looking at a phone screen, an iPad screen, a tablet screen, a laptop screen, a computer screen, a TV. Any of those, they're all rectangles. We've got lots of rectangles in real life. A lot of windows are rectangular. Books, a lot of books are rectangular. Lots and lots of different things, rectangles. Okay, can you add the following lengths? So 6 centimeters add 6 centimeters. You should have got the answer to that is 12 centimeters. And 4 centimeters add 4 centimeters is obviously 8 centimeters. Fantastic. Let's move on and start looking at our actual lesson. So Max, Aki, and Amelia are swimming in a rectangular pool. Okay, so just here we can see that this pool in the picture is rectangular. Max says that he's going to swim. Max says that he's going to swim the width of the pool. Aki says that he's going to swim the length of the pool. Amelia said that she's going to swim all the way around. How will, a couple of questions to think about first. How will Amelia know that she's gone once around the whole pool? How will she know once she's made it once all the way around? Okay, have a think about that one. In the picture, who do you think will swim the furthest? Max swimming the length, Max swimming the width, Aki swimming the length, or Amelia swimming all the way around? Who's going to swim the furthest and why? Who will swim the shortest distance? And can you use your finger to trace the path that each child will swim? Pause the video here. Have a go at tracing your finger to the path that each child's going to swim. So Amelia's might be in a rectangle all the way around because she's going all the way around our rectangular pool. Aki's is going to be across and Max's is going to be the width. Try and path the trace the path that each child's going to swim with your finger, and then we'll come back and we'll draw it on. Okay, so from the picture we saw that Max is going to swim 4 meters, Aki's going to swim 10 meters. We want to work out what distance Amelia is going to swim. Let's start by drawing on each person's swimming path in the pool. So let's make Max orange, and he said that he wants to swim the width. Now the width is only 4 meters. Max is swimming the width that's 4 meters. Now, this is confusing because when I did length and width last week, I thought that length was always this way and width was always this way. But you've got to imagine that there's a person stood here looking at them. Okay, if this person is stood here, oops, oh, and they are looking out at the pool in that direction, that is going to be the width and that's going to be the length, okay? So Max is swimming the width. We've drawn that on. It's orange, 4 meters. Aki is swimming 10 meters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, he's swimming the length of the pool. What distance will Amelia swim? Right, Amelia's going to be pink. So see, she's going to start at this corner. She wants to swim all the way around the pool once. All the way around, keep going. That's how far Amelia's swimming. So when we think about who's swimming the least, who's got the shortest line? It's going to be Max, isn't it? And then who's going to swim the longest? Well, I mean, there looks like there's a lot of pink on there, so I think Amelia is going to swim the longest. Let's find out. So, can we use the length? So I've got the length of the pool. So here's 10 meters the length, 4 meters the width. Now, I haven't got the length of this side or the width of this side. There's nothing there. Can I use any of my other sides to find out these missing ones? Have a think about it, and then we'll talk. Okay, so I can. Like we said earlier, these rectangles all have 2 sets of equal sides. So what that tells me is that if that side is 10 meters, let's change the color to blue. If that side's 10 meters, this side is also 10 meters because those 2 are equal sides. And if this one's 4 meters, this side is also going to be 4 meters. Okay? Then once we know all the sides, how do we work out how far Amelia swam? So the distance, the whole way around the outside of a shape, is called the perimeter. Now that means that Amelia swam the perimeter of the pool. And the way that I work this out is I need to add all of those lengths together. So I need to do 10, add 4, add 10, add 4. I want to add them all together. So 10 add 4 is 14, add 10 is 24, add 4 is 28, which means that Amelia swam 28 meters. Okay, so Max swam 4. Let's write them on. Max swam 4 meters. Aki swam 10 meters. And Amelia swam 28 meters. So Amelia did swim the longest. Okay, here's another shape. Let's see if we can work out, I'm going to move this over here. Let's see if we can work out the perimeter of this shape together. So we've got 4 centimeters across here, 5 centimeters down here. This is just, this where it says 1 centimeter is just telling us that each square is worth 1 centimeter. And we can see that because if this is 4 centimeters at the top, and we've got 1, 2, 3, 4 squares, that matches up. Right. 4 centimeters, and it's the same as this side because there's 2 equal sets of sides. That means that one's going to be 4 meters, 4 centimeters, 5 centimeters. That means this one's going to be the same, 5 centimeters. So now I've got all of those sides. They're just the same on either side. Now that I've got 4 sides, I can add them all together. So 5, add 5. 5 centimeters, add 5 centimeters is 10 centimeters. And then 4 centimeters, oops, add 4 centimeters is 8 centimeters. And then I can do 10 add 8 equals 18 centimeters. So my perimeter is 8 centimeters, 18 centimeters. Okay. Hopefully that's helped you a bit, ready for your guided practice. Now, you're not given the sides on all of these, but remember what we said when each square is 1 centimeter. So let's do the first one together. Let's do A. So we have got, let's count those squares. We've got 1, 2, 3, 4, 5, which means that this side is 5 centimeters. Red, a bit smaller, 5 centimeters there. And then we've got 1, 2, 3, 4, 5, 6, 7 at the top. So this one is 7 centimeters. And now I know that this side is also going to be 7 down here, and this side is also going to be 5 up here, which means that 7 add 7 is 14, 5 add 5 is 10, 14 add 10, so 7, let's type it at the bottom, 7 add 7, I don't know why it keeps that here there, 7 add 7, oh god, add 5, add 5, is going to give me 14, 10, which makes 24 in total. Okay, pause here, have a go at the other two, and then we'll come back and we'll look at some apply questions. Okay, guys. Right. Hopefully that was okay. If you need some help, drop us a message. We can have a go at it together. We can give you some help, okay? Let's move on to the apply and have a look. So we have got 3 questions here. First one, each lolly stick is 8 centimeters long. Find the perimeter of the shape. So each lolly stick is 8 centimeters long. That's very important. And then I need to think about how many lolly sticks I've got. So I've got 1, 2, 3. So what's 3 times 8? Because that's going to give me that side. And then 1 here, which is going to mean that these sides are 8 centimeters long. Okay, there's your hint. So you can work that one out. Next one, Eva is finding the perimeter of the rectangle. So here's her rectangle. It's 5 centimeters, 10 centimeters. I added the length and the width. So she's added 10 and 5. She added those together and then multiplied by 2. So she did 5 centimeters, add 10 centimeters is 15. And then 15 times by 2 is 30, which is a great way to do it. It saves you doing add. Okay. Can you try using Eva's method to find the perimeter of these 2 rectangles? So for example, 6 add 16. I'm going to add my length and width. 6 add 16 is 22. 22 times by 2 is 44. So the perimeter of this one is 44. You can work it out in another way to double check your answer, but that would be correct, okay? Try and work those 2 out using Eva's method. We've just done the first one together. And then you've got a Going Deeper challenge that I'd love for everyone to have a go at. So I've got a swimming pool here, but part of it's been covered over by the tarp. Now I can measure this side and I can measure this side. I've measured 2 sides of this swimming pool, but I can't measure this one and I can't measure that one because they're covered over. So I don't think I can work out the perimeter of this shape. Now I'm wrong there. I can still work out the perimeter of this shape, and we've talked about it in this lesson a couple of times. Why, now that I know these two sides, how is that going to help me work out the length and width of the other two sides that are covered and the perimeter as a whole? Please explain that to me. Try and use mathematical language that we've looked at today, okay? Pause here, have a go at those 3 questions, come back, and we'll move on. Okay, let's look at the plenary. Each of these rectangles has a perimeter of 24 centimeters. Work out the missing lengths and label the diagrams, okay? Now we can do the first one together and then we'll go off and you can go off and you can do the second one on your own, okay? Right, each of these rectangles has a perimeter of 24 centimeters. That means that all 4 sides add up to make 24. Now, I don't need to worry about those last 2 sides. I only need to worry about these 2. But that means that I'm going to have to halve 22. So 22 divided by 2, so half of 22 is 24, sorry. 24 divided by 2 is 12. So these 2 sides should add up to 12, which means that if one's 10, the other one must be 2. And then same again, half of this perimeter, it's these 2 sides, the length and the width. If we think about Eva's method of timesing by 2, dividing by 2 is going to give me the length and the width. So the length and the width of this one is 12. Well, if one's 9, what do I need to add to 9 to make 12? Easy peasy. Once you've done your work, hand it in on Teams or through the email. Again, if you need help, you can ask us, drop us a message on Teams, drop us an email. We can help you where we can. Hopefully this wasn't too tricky. We're going to be going a bit more in depth with it tomorrow and Thursday. So yeah, we'll see you soon, guys. See you later. Bye.